Have you ever wanted to add telemetry to your RC car, boat, or robot, but found that commercial systems are expensive, proprietary, complicated, and impossible to customize? That's exactly why today we're going to build our own, a full RC touchscreen telemetry system for under $40 using a small computer called the ESP32. And even if you've never touched a microcontroller before, don't worry, you're in the right place. What if we could see our battery voltage, current draw, GPS information, compass orientation, battery temperature, and even add extra servo and lighting channels all on a tiny portable touchscreen? In the last video, we built our own 4-channel RC transmitter and receiver using ESP-NOW. Today, we're going to take things to the next level and use the ESP32 as a pure telemetry smart add-on to your existing RC setup. Adding a microcontroller to our RC setups opens a ton of customization possibilities. For many small RC and robotic projects, a standard affordable modern radio works great, and it's a reliable and fast way to get up and running. Unfortunately, these radios lack many useful features found in more expensive RC radio setups. We're going to use an ESP32, a tiny computer that has different input and output pins that we can use for whatever we want. There are hundreds of different compatible sensor modules available, including GPS, barometer, gyroscope, and much more, so depending on your project, you can easily customize this for your setup. We're going to use a full-size ESP32 today. We can also use the ESP32 Super Mini for tiny builds where space is tight. This telemetry system uses two ESP32 boards communicating wirelessly over a protocol called ESP-NOW. Think of it like a direct radio link between two devices. This ESP32 is the brain going inside the car. It connects to all the sensors and sends the data back to the ground station. The other ESP32 has a built-in touchscreen. It's called a CYD or cheap yellow display. Let's take a look at the dashboard. We are measuring power consumption, temperature and humidity, distance to object, we're calculating G-force, we're calculating speed, we have our compass heading, pitch and roll, altitude, along with other GPS data. We've included a separate page for controlling 2 electronic speed controllers and 2 servos. We're going to use the following modules. You don't need all of these sensors for this to work. All modules mentioned here can be powered with 3.3 or 5 volts directly from the ESP32, or in this case, I'm using 5 volts from the battery eliminator circuit. The INA219 is the power sensor that connects to the ESP32 over I2C connection, so we have SDA and SCL lines. This module's terminal block sits in line with your battery lead as shown here, so it can measure real-time current draw. For this, I made a custom cable to tap into the battery line using JST connectors. Keep in mind this module can only measure current up to 3.2 amps, so for larger RC vehicles, we'll need to swap this out for a higher current module. The MPU6050 is a gyroscope and accelerometer module, so it can calculate things like G-force and pitch and roll orientation. Great for things like rock crawlers and drones. Mount this correctly in your chassis for accurate orientation readings. This also runs on the I2C bus, so it shares the same 2 data pins with the power module. We're using this for pitch and roll to determine the angle of the vehicle. The gauges turn red to indicate that the vehicle is in tilt. We are also using this module to calculate overall G-force, so we can do things like monitor new suspension setup improvements, so you can tune things for a smooth ride and also detect crash impacts. This is a simple DHT11 temperature and humidity sensor. We can use this to measure motor or battery temperature. We're going to use this VL53L0X time of flight distance laser sensor to detect objects in front of the vehicle. This is also included on our I2C bus. Let's kick things up for this version and use a BN880 GPS module with built-in compass. The compass will join things over I2C, while the GPS module uses dedicated RX and TX pins to send GPS data to the ESP32. We've included a home feature and an on-screen compass heading as well. Tap the compass to reset your home position. This module allows us access to a lot of information, such as altitude, speed, compass heading, and more, and it will help us for future robotic projects. We made a Y cable to split all the sensors in parallel. Each module on the I2C bus has its own unique address, so you can connect multiple devices to this bus. In this case, we're using 4 modules on our I2C bus. Once you have everything connected, run this I2C scanner to find the exact address of your modules, as they vary from different manufacturers. It's also a good way to confirm everything is wired up correctly. These sensors can be bought online for just a few dollars each. The onboard ESP32 can be powered from a 5-volt converter, your ESC 5V BEC, or a USB battery bank. On the touchscreen side, there's no extra wiring needed. It's all built in. Just plug it in via USB-C to a USB battery bank. If you're new to Arduino, full setup instructions are on the website. There's 2 sketches that can be found in the link in the description. There's one for the CYD and one for the onboard ESP32. Each ESP32 has its own MAC address, which is basically like a network serial number for the unit. You can get the MAC address by uploading any sketch to the board and looking at the IDE output, or you can run this sketch here that will print the MAC address of the board to the serial monitor for you. So in the ground station sketch, you're going to paste in the MAC address of your receiver. In the receiver sketch, you're going to paste in the MAC address of your CYD. Both boards will then always automatically pair with each other on boot. You can use this as a base for your telemetry system and easily customize it to your needs. We can also fully control the RC vehicle from the servo page via a joystick, or use the extra channels for an RC winch or servo. The best part of building this yourself is that it is fully customizable, plus it's way more fun to build our own from scratch. If we wanted to, we can make the RC car fully autonomous by responding to its location via GPS and waypoints. We can add a buzzer feature to locate a lost drone or vehicle. We can add encoder data from the motor and combine that with GPS data to get even more accurate speed readings. This is just an example of what's possible with ESP32. Once you understand the basics, you can build your own custom systems, add the sensors you need, and create features tailored specifically for your projects. Thanks for watching the video. We'll definitely be adding to this, so make sure you subscribe so you don't miss it. If you want to check it out, the code and any files you need are linked in the description. Make sure to drop any questions below, and we'll see you in the next one.